All right, let's practice writing linear equations in the standard form. Um, and you know what? When I was in school, I thought the standard form was weird, and I just wanted to use slope-intercept. But standard is pretty cool. Um, for one thing, sometimes you can't write equations in the slope-intercept form. Um, if a line has an undefined slope, what are you gonna do? Second of all, I don't know. Standard form just kind of looks cool. Ax plus by equals c. It's nothing to worry about. I'm kind of OCD. I'm trying to line these things up. So what this really means is something times x plus something else times y equals something else. And so a, b, and c are integers. It's nice if they're not fractions or decimals. And it's also really nice if a is not a negative number. And you can do stuff, if you've got a fraction or if you've got a negative number, you can always um, multiply um, the whole equation by things to kind of undo that and kind of clean up the equation, which I'll show you over here. But really, what you want for it to be in truly standard form, a, b, and c are integers, and then a is not a negative integer. So yes. All right. So here's an example: 3x plus 2y equals 18. 3, 2, and 18 are integers. The coefficient of x is not a negative integer. So, nice little standard form. So let's try it. Let's practice converting various equations into that form. So here I've got a line in the slope-intercept form, classic. But let's turn it into something that looks like this. So I notice that x and y are over on one side, and then there's just a number on the right side. So why don't we just first step? I'm thinking why not move the x over to the other side of the equation? So we'll um, subtract 3/4 x from both sides just to move it over. In other words, if I move anything from one side of the equation to the other, I just flip the sign. So this will be gone here, but then I'll have a negative 3/4 x over on the other side. So I'm going to write it like we have so far as negative 3/4 x plus y. And actually, I'm going to go ahead and just write that as 1y. I just want to make it look more and more like this. Negative 3/4 x plus 1y, same thing as y, right, equals 5. So already we're pretty close, um, but this thing needs to be an integer, not a fraction, and we'd also like it to be positive. So let's just do that in one step here. Um, so it's being divided by 4. This negative 3 is being divided by 4. That's what is making it into a fraction. So if I multiply by 4, that'll take care of it being a fraction. And if I multiply by negative 4, uh, then it'll flip the sign. So I'm going to multiply everything by negative 4. Both sides of the equation I'll multiply by negative 4. So you can do anything you want to an equation as long as you do it to both sides. Um, so I'm going to multiply everything by negative 4, and so the equation will still be balanced, it'll still be true. But what it'll do is it'll solve this problem of this being a fraction and being negative. So uh, um, negative 4 times negative 3/4 would be, so you can think of this as negative 4 over 1 times negative 3 over 4. Negative 4 times negative 3 is just positive 12. 12 divided by 4 is 3, right? So this just becomes 3x when I multiply negative 3/4 x by negative 4. It just becomes 3x. So solve that problem. So now, I have to do that to everything now because, I can't just decide, oh, I'm going to make this into a 3x. I've got to keep the equation balanced. So negative 4 um, times uh, 1y would be negative 4y. And then 5 times negative 4 would be negative 20. So it's okay if the other guys are negative integers. It's just nice when x is not. Um, so our standard form of this equation would be 3x plus negative 4y is equal to negative 20. All right, let's try an equation in the point slope form. That's this. It's a point slope form. Another useful form. Um, but looks a little bit messier than standard form. So let's deal with that. So I want to get it something like this, where there's x and y over on one side, and then just some number on the other side. So x is kind of being caught up in the parentheses here. It's involved in a lot of stuff. So let's rescue it. So we're gonna distribute that 3. Just kind of clarifies the situation over there. And 3x minus 15 is what that would be. Could expand that to 3x minus 15. So we got y plus 7 equals 3x minus 15. Now, I want to get the x's and y's over on one side, so I'm going to subtract that 3x just to move it over to the other side. Okay, so we've got negative 3x plus y plus that 7 yet is equal to negative 15. Now let's go ahead and move that 7. We just want x's and y over here. Nobody else allowed, so we're going to move that 7. So we've got negative 3x plus y equals whatever that is, negative 22. Yeah. All right. And we can look at this as 1y. Now this is a negative 3. So what we'd like to do is make that positive, so we can multiply everything by negative 1. So basically flip the signs of everything. So negative 1 times negative 3 is just 3. So that's 3x plus negative 1y. So negative 1 times 1 is negative 1y. And then negative 22 times negative 1 would just be 22. So here we go. So a, b, and c are integers, and a is no longer negative. So we call that, standard form. That's looking pretty good. All right. Let us do one more. 6x minus 5 equals 15y plus 3. That's not in any particular handy form. So it's just, whatever. So we can turn it into standard forms. Let's get the x's and y's together. So, minus 15y to get it over on the left side. And then plus 5 to get that 5 over on the other side. You can think of that as minus negative 5, by the way. Okay, so when we do that, we get 6x minus 15y is equal to, okay, so this is gone. That 5 we moved over to the other side, so 3 plus 5 is 8. And actually, we're good to go because a, b, well, let's see, we can call that plus negative 15. Sorry, alright. 6x plus negative 15y equals 8. So a, b, and c are integers, and not a fraction or a decimal or anything. And a isn't negative, so that's good. And so we're good to go. That's the standard form of that equation. All right. So I've given you 3 problems to try. Try converting those into standard form. I don't know if I have. I don't think there's an example here, but if it's okay if these coefficients are 0. That's fine. If you don't have an x, just call that 0x, right? So if you have a line that's like a horizontal line, it's like here I am. So it'd be like y equals 2 or something. You can write that in standard form. There's no x there, so just call it 0x. Anyway, just a little side note. All right, enjoy.